Okay, so today, the tide problem. That's what I like to call it. So Bill and Lana were sitting on the dock of the bay, just wasting time away, just sitting on the dock of the bay, watching the tide roll. Anyway, as they sat there, they noticed that the high tide was 2 a.m. at a height of 5 meters, and low tide was 10:30 a.m. height of -1 meter. So what I want to do first is get a 24-hour graph. So I'm going to start with midnight. Let's do midnight here. I'm going to go 1 a.m., 2, 3, 4, 5, 6. I'm going to do the whole thing. 7, 8, 9, 10, 11, 12. Now I'm going to use military time. We call it military time, okay? 13, which is 1 o'clock, 14, which is 2 o'clock, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24, which puts me back at midnight, right? I've got noon right here, okay? So this is my AM, and this is my PM, okay? This is going to be the height of the tide, or my dock, and I'm going to have a low tide of -1 when the tide's way far out. It's like a negative tide because it's less than sea level, because all the rest of the water is bulging over by China. Does that make sense? So the moon pulls the ocean toward it, and at high tide, it's going to empty out the other side of the earth, and that's how you get a low tide. Okay, so a -1 tide doesn't mean there's any water there. It just means it's 1 foot lower, 1 meter lower than what we call sea level. Right? Make sense? Okay, so I've got 1, 2, 3, 4, 5. Okay, so I'm going to do a dot to dot to start off with. 2 o'clock a.m. I'm going to put a dot at 1, 2, 3, 4, 5. So I've got a height of 5 meters at 2 o'clock. Now, I'm also going to put a dot at low tide. So 10:30, I'll put a dot at -1, which is about there. Okay. So what I want to do first, before I do anything, is I want to find out when the next high tide is so that I can start to draw on my curve. Okay. So my next high tide, let's see. First of all, what is the time of a half tide? So the time of my I call it a half tide.
Can I just get a new one? I really messed this up.
Sure. Okay. So when I call it a half tide, I'm talking about from high tide to low tide, right? Does that make sense? So that's from 10:30 to 2. So that's like 10:30 to 2 o'clock should be what, 7.5 hours? 8.5 hours, right? So that's 8.5 hours, or 8.5 hours is a half tide, right? So if I want the full tide, I'm just going to double that, right? So full tide, yeah, I'll slow down, okay? So I know the time. Yeah, oh yeah, sorry, how about that right there? So the time between 2 to 10:30, I'm off a little bit of my 10:30, aren't I? I am a little bit off of my 10:30 right about there. Okay, there you go. So my time from 2 to 10:30 is 8.5 hours, right? So then if I do another 8.5 hours, I can get a full tide. From high tide to high tide is full tide, okay? So the length, or the time of a full tide, meaning, high tide to high tide, right? High tide to high tide is going to be 8.5 times 2, which is 17, right? 17? So 17 hours, okay? So one full tide is about 17 hours, right?
Wait, but the next high tide's at 7, right?
You're ahead of me, and the answer is yes, but I'm going to get there, okay? Okay, let me get there. So, when is the next high tide? Well, if we go from 3 o'clock a.m. and we add 17 hours, right? Because we go high tide to high tide, right? 3 o'clock in the morning, go 17 hours, we're going to get to 20 o'clock military time, right?
high tide is at 2, by the way.
But that's going to be
2 plus 7.
that's going to be 8 o'clock in the evening, or 8 o'clock p.m. And I'll take either one, but 8 o'clock p.m. is easier for us since we're used to a.m. p.m. Yeah, Ben?
Why are we doing 3? High tide.
Oh, 2. Sorry, my bad. 2. Gosh darn it. 19. Right, 19. I did make a mistake. Isn't it 19? Which is 7. Thanks, Ben. Oh, my brain is really foggy. All right, there we go. Thank you, Ben. Did you guys see my mistake?
Hard alcohol might help with your brain.
I don't know. I'm going to stay away from that, Ben. Okay, now, so my next high tide is either 1900, as far as the military time, or 7 o'clock p.m., all right? Now, an equation. Here's what we need. First of all, if I were to go ahead and put in my 1900, right? And I'm going to try and sketch in my curve. Now, like Cody brought up a really good point. Why isn't it pointy? Why is it curvy? And we went through it. So when we do graph it, let's draw it curvy. It's a cosine curve, right? So it's going to look something like this. Okay? And it goes on and on, up and down throughout, the eons. Tide's been going on forever, right? So to me, it could be the two graphs we look at are either this graph, that's a sine, or it could be this graph, which is a cosine, okay? I think it's cosine. I think it matches up to a cosine better than a sine. You guys see the difference?
Yes.
So to find the equation, I'm going to go straight to a y equals cosine. So let's start right off with cosine, okay? Now the amplitude. We also need the amplitude, okay? So to find the amplitude, please write this down. To find the amplitude from a graph, it's always the max minus the min divided by 2. Okay, that's the amplitude. It is the max minus the min divided by 2. Okay, so for us, the max is 5, that's high tide, minus the min, which is -1 because that's low tide, divided by 2,
3.
which is 6 over 2, which is 3. So my amplitude is 3. In fact, I'll slide the graph back down. You kind of see the middle of the graph right here, and it looks like it goes up 3, down 3, right? Or it's got a spread of 6, halfway is 3, okay? But the little formula will always work for you, okay? Now, we also need to find b, which is the frequency. Okay, so to find b, which goes right here in my cosine graph, b is equal to 2 pi divided by the width. Okay? The width of this graph is 17 because it's 17 hours from high tide to high tide. That's my width because my axes are in terms of time, right? So my width has to be at time, and our width is 17, so our b is 2 pi over 17. So I'm going to put that in there for b. So I'm going to have 2 pi divided by 17. Now, high tide did not occur at midnight. It occurred 2 hours after midnight, right? So there's definitely a horizontal shift of 2. But it's the opposite. Instead of plus 2, it's really going to be minus 2, right? So it's going to be I'm going to use t instead of x, t minus 2, okay? And that gives me the horizontal shift. Now, the graph itself has been brought up. If you look at the middle of the curve, okay, the graph itself has been moved up 2. Now, if you're not sure how to do that, to get k, the value of k, a little formula for k is always going to be the minimum plus your amplitude. You can always get the value of k by taking the minimum, which is -1, plus 3, which is the amplitude, which is 2, right? Or if you can just see it, you know it's 2, okay? So this is going to be plus 2, okay? There is my equation. How am I doing?
Great.
Now, what is the height of the tide at noon? Well, we could guess if I look at my graph, but I want it accurate.
Equal to 12.
You're right. Put it right, Ben. So if I look at 12, it looks like it's right about here. It looks like it's about -1. It's close to -1, right? But I drew it, so how accurate is it? I don't know. But Ben's right. So what I'm going to do is let t equal 12, okay? All right, so I'm going to go ahead and plug in y equals 3 cosine of 2 pi over 17 times 12 minus 2 plus 2, right? Now I want to put this in my calculator. Before I do anything, real big star, radian mode. I have to be in radian mode because I'm going to use my calculator, and I've got pi in there, not degrees, pi, right?
I have a
So,
question.
yeah,
Wait, why did we choose 12 again?
noon,
Okay.
right? Good question, right there.
Where
So-
is big star?
So, radian mode. So I'm going to go into my calculator, I'm going to double check my mode, and I'm going to make sure I go from degree mode to radian mode, because if I use my calculator, and I'm going to do sine, cosine, or tangent, I'm either going to do things in terms of degrees. Just a second. I'm either going to do things in terms of degrees or in terms of radians. This one's definitely in terms of radians because of the 2 pi, right? Okay, Ben, did you see it? I went to mode, went down and changed it from degree to radians, okay? Now, to make this a little bit less cumbersome, I'm going to do a little extra work just because it's worth it to me. So, for me, first of all, I can make that a 10, right? That's just a 10, you guys agree? And I'm also going to figure out what's 2 pi over 17. Let's figure out what that is as a decimal. It's just going to make it easier for me. So I'm going to figure out what is 2 pi divided by 17. I'm going to use my calculator to figure that out. I'm just trying to make this easier to put in my calculator because there's a lot of stuff to put in my calculator, right? So, okay, what is 2, oops, clear that, 2 pi divided by 17. And I get an answer of about, no, that's not it. 2 pi divided by 17. About 0.37, okay? So it's about 0.37. So here's what I'm going to use, my calculator. So my calculator, I'm going to go ahead and put the following in. I'm going to go I'm going to go 3 cosine of 0.37 times my 10 plus 2, okay? And before I hit my calculator, I'll go back through what I did. 0.37 is 2 pi over 17. 12 minus 2 is 10. Just going to make it easier to put in the calculator. You guys agree with that? So less steps. So I'm going to go ahead and just put that in my calculator. I'm going to go 3 cosine of my 0.37 times 10 plus 2. And I get an answer about negative 0.54. So negative 0.54, and that's in terms of meters, and that's the height of the tide. That's where the height of the tide is at noon, okay? Thumbs up. Okay. Before I quit, make sure you have these formulas. Amplitude, finding the B, and finding K. These are really going to help a whole lot on today's homework, okay? So let me go ahead and stop recording.